Hello, class. This is the answers for that course readiness assessment that we had in class. This first question here wants us to factor x squared plus 2x minus 8. So factoring this would amount to finding what two numbers multiplied to make negative 8 and add to make positive 2, which, in our case, for the 2 to be positive in the middle there, we need a positive 4 and a negative 2 to multiply to make the negative 8 and add to make positive 2. So this is going to factor to x minus 2 times x plus 4. The second one also wanted to factor. This one, though, is an 9x squared minus 4. The 9 and the 4 are both perfect squares. So this is one of those formula-based ones. The difference of two perfect squares. So these just differ in sign. One will have a positive, one will have a minus. This is going to be 3x plus 2 and 3x minus 2. And the square root of 9 is 3, and the square root of 4 is 2, which is where that difference of two perfect squares comes into play with the formula. The third one, one of the roots of the polynomial. So we need to actually set these equal to 0 afterwards. 2x squared plus 7x plus 3. So finding the roots of this one, again, amounts to setting this equal to 0. We need the first term to multiply to make a 2. So one needs to be a 2x, the other one needs to be an x. The last term needs to be a 3, but we need to somehow make a combination of these factors to get the 7x. So we're going to want to multiply the 2x by 3 and the 1x by just 1. And everything is positive. In terms of the factoring, to get the actual roots, we set each one of these equal to 0. So 2x plus 1, 2x plus 1, there we go, is equal to 0. So x is going to be negative a half versus x plus 3 is equal to 0, which amounts to x being negative 3. The fourth one of this one, the equation of the line that goes through these 2 points, the points 5, 1 and 7, 4. So in this case, we first need to find the slope. So that's the change in y divided by the change in x. Which one's first doesn't particularly matter as long as you're consistent. So I'm going to do 4 minus 1 divided by 7 minus 5. So this would give us a fraction of 3 halves, which makes sense, right? You go up 3 to the right 2 to go between the 2 points. Since we want the equation of a line, in the point slope form, this is y minus 1 is equal to 3 halves times x minus 5. It didn't specify which way we want this. So we could certainly leave it like this and say, yes, this is the equation of a line. Going through those 2 points, and you'd be 100% correct. If you wanted to put it in that slope-intercept form, however, we would first distribute this 3 halves and then add over the 1. So y would be 3 halves x minus 15 halves plus 1. So the equation would be y is equal to 3 halves x minus 13 halves. The fifth one wants the equation of the line that has a slope of 5 and y-intercept of 3. So this one is just going to be y is equal to 5x plus 3. If you want to put the point in there for us to actually use the equation for it, that point was 0, 3. But it should still give that b value in the slope-intercept form to just be a value of 3. This sixth one here wants to sketch this curve given by y is equal to x halves minus 2. So this is technically not a curve, but neither here nor there. I'm just going to sketch out a Cartesian coordinate plane. And let me just note these points in blue to try to distinguish what we're doing. So due to that y-intercept here of this -2, the first point we're going to have is 0, -2. To get the next point, we're going to use that slope of up 1 to the right 2. So 2, -1 is a second point. And I'm going to do a third, just so it crosses the x-axis and makes a straight line. You don't have to in order to actually answer this, but up 1 and to the right 2 again, this is 4, 0 for that x-intercept. So there. So connecting these to get a line, and presuming I draw this straight on camera here, but something, slightly off. Something like that. It's a straight line with a slope of 1/2. Our third one here, we want to perform this indicate operation to write the expression as a single fraction, x over x plus 3 minus x minus 2 over x plus 1. So since these don't have a common denominator, we need to multiply them to get that common denominator and rewrite the numerators as appropriately. X plus 3 times x plus 1 is going to be each denominator. The numerator, since this left rational fraction here just had that denominator of x plus 3, we're going to multiply this numerator by x plus 1 minus. We have x plus 3 times x plus 1 in the denominator. We're multiplying the numerator of that rightmost rational expression by x plus 3. So x minus 2 times x plus 3. So in order for us to actually write this as a single expression, we need to multiply each respective numerator. And I'm going to also put this over the common denominator, so it's all under one fraction. X plus 3 times x plus 1 in that denominator. We have x squared plus x from the leftmost fraction. From the right one, we have a minus x squared plus x minus 6. So simplifying this, yes, these x squares cancel, these x's cancel. So all that we're left with in this fraction is -6, so +6, divided by x plus 3 times x plus 1. The eighth one wants us to rationalize this denominator, so 5 divided by the square root of 3 plus 2, which means that we are multiplying by the conjugate. What does that mean? It's almost the same expression as that denominator, just with a minus instead of a plus. So square root of 3 minus 2, square root of 3 minus 2, to both the numerator and the denominator. So that numerator just becomes 5 times the square root of 3 minus 2. The denominator becomes, due to the fact that we're just multiplying by that conjugate, this is going to make 3 since the two square roots, the square root portion disappears since we're multiplying these two. The two middle terms that would combine from multiplying two binomials, those disappear since they cancel out, and we're just left with a -4. So cleaning this up, this makes 5 times the square root of 3 minus 10 divided by -1. So let's simplify this further. -5 times the square root of 3 plus 10. Number 9 wants to simplify this expression as much as possible. 16 to the 3/4. This is the same thing as the 4th root of 16 cubed. Now we can see from this, 2 to the 4th power makes 16. So we could simplify this to just being 2 cubed. And that just gives us a value of 8 for this particular expression in order for us to simplify it. Number 10 wants us to simplify this as much as possible. X squared times y cubed times z to the -4th, all divided by the square root of x times y squared times z. So we need to subtract exponents based on these like variables. So for the x's, this is 2 minus a half for that square root. So this is going to give us x to the 3/2. I'm subtracting those. Y cubed and y squared, subtracting those exponents just gives us a y to the 1st power. And z to the -4th divided by z gives us z to the -5th. So z to the 5th would be in the denominator. So x to the 3/2 times y divided by z to the 5th power. The 11th one wants to simplify this one as much as possible. The square root of x squared times y cubed in that numerator divided by x to the 4th times y, that expression cubed in the denominator. So that numerator, we could simplify this to be x times y to the 3/2 divided by, we could simplify the denominator by cubing both of these, x to the 12th times y cubed. And then again, we could subtract in this one. X to the 1st over x to the 12th, this makes x to the -11th. So x to the 11th in the denominator. Y to the 3/2 divided by y cubed. So this is going to make 3/2 minus 3. So -3/2. So y to the 3/2 would be in the denominator. And the numerator would just have a 1 in it. Number 12, which is something we're going to be seeing a lot in calculus. But we want f of x to be x squared plus 3x, and we want to find f of x plus h minus f of x. So f of x plus h, replacing all the x's in this expression with an x plus h. We work like this. X plus h squared plus 3 times x plus h. Multiplying this out, this is going to make x squared plus 2xh plus h squared plus 3x plus 3h. And f of x, I'm just going to rewrite this, is x squared plus 3x. And we're going to want to subtract these two, right? So we could already cancel out two things, these x squares and this 3x. So the subtraction of f of x plus h minus f of x is 2xh plus h squared plus 3h. Number 13 wants us to solve for x in this particular equation. X times x minus 3 is equal to -3 times x minus 12. Distributing on both sides of the equality, we get x squared minus 3x is equal to -3x plus 36. We can add over the 3x, which just cancels them out, and make x squared is equal to 36. And applying the square root to both sides gives us an answer of positive and -6. So 2 answers to that. And then the last one here, number 14, we want to solve this for x, leaving our answer in radical form since this does not make a nice number. The x, this makes x squared minus x. We could subtract over the 16 is equal to 0. The problem, though, is there's no factors of 16, of negative 16 anyway, that somehow combine to make a negative 1. So quadratic formula. A is 1, B is negative 1, and C is negative 16. That formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So in our case, 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 16, all divided by 2 times 1. So 1 plus or minus the square root of 1 plus 64 divided by 2. So 1 plus or minus the square root of 65 divided by 2. So let me know if you have any questions or concerns. Thank you.